Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to explain the formula that appear when we discuss about arithmetic sequence and series. In arithmetic sequence, we write the terms of the sequence like this. That is first one A1, that's the first term, and then we write A2 as the second term. This will be our third term, A3, and so on and so forth up to AN. Or maybe the sequence is an infinite sequence, so we can proceed up to infinity. So the difference between the first term and the second term, that is the difference between A1 and A2, is D. That is the common difference, we call it. Okay, the same thing, the difference between the second term and the third term, also D. Okay, that is the common difference. Okay, that's the same as we go along the sequence. The difference between any two consecutive terms will be equal to D. So in this case, we have A1 will be our first term. The A2 is our second term. Okay, and so on. We have up to AN. Okay, this will be our nth term. Now D, okay, as we mentioned, D, we call it common difference. Okay, so now let's discuss one example of an arithmetic sequence. For example, if we have a sequence of odd numbers, okay, start with 1, and then we have 3, we have 5, we have 7, okay, sequence of odd numbers goes to infinity. Therefore, in this case we have A1 equal to 1, D equal to 2. Okay, for this example, can we find what is terms number? For example, terms number 100 is equal to what? What is the terms number 100? What is A100? How to find it out? Do we need to list, okay, all the terms, okay, in this sequence up to terms number 100, and only then we can tell what is terms number 100? That is very tedious and take a lot of time to do. Okay, luckily we have a formula that can help us to solve that problem, and that formula is this one. That is AN is equal to A1 plus N minus 1, okay, multiplied by D. Okay, where AN is the nth term, A1 is the first term, N is the number of term in the sequence, and D, okay, D is the common difference. So we can apply this formula, that is this formula, to find, okay, certain number in the terms. For example, A100, like for that example here. Okay, now can we find terms number 100, that is A100, by using this formula? So let's try it. Terms number 100, okay, that is referring to this sequence, that is the sequence of odd numbers. A1 equal to 1 and D equal to 2. So let's substitute the values for A1 equal to 1 plus, okay, N in this case is this value here, that is 100. So 100 minus 1, okay, multiplied by D. D is the common difference. Okay, see here the common difference between 1 and 3 is 2. 3 and 5 also 2. 5 and 7. All the difference between any two consecutive terms, they are all equal to 2. The difference is equal to 2. So now let's multiplied by d, and in this case d equal to 2. Correct. So we have here is equal to 1 plus 100 minus 1 is 99, okay, times 2. Alright, so we have this is equal to 1 plus, okay, 8, and we have 198. 99 times 2 is 198. Therefore, the answer is 199. Okay. Now, what that means is terms number 100 is this number. Okay, this number, that is 199. Okay, it shows that this formula, okay, can help us to find certain terms in the sequence, okay, without having to list all the terms. Meaning to say, this formula can help us to find the terms in the sequence very quickly and very fast. So this formula is very useful then, right? This formula is very useful. Okay, but the question arises that how we get this formula? How we get this formula here? Okay, that is an equal to a1 plus n minus 1 times d. How you come about explaining the formula? Okay, what is the way? What is the origin of the formula? Where it's come from? Okay, maybe we can take some time to explain that. Okay, that is where this formula, okay, an equal to a1 plus n minus 1 times d. Now, where this formula comes from? Okay, now we are going to explain that. Now, as we mentioned a few minutes ago, that in arithmetic sequence, we can write our terms like this. That is a1, the first term, and then a2, and then a3, and then suppose that we have only up to nth term. Okay, after the nth term, the sequence stops. Okay, so we have finite sequence in this case. Okay, and we have the last term here is the nth term. Okay, and the difference between, as we mentioned, the arithmetic sequence, they have common difference. So between any two consecutive terms, they have common difference d, right? So that's d there. And also we have the difference between a2 and a3, that is a3 minus a2, also equal to d. They have common difference like that. Okay, so I would like to write down now, okay, the first term is a1, like this. Now, what is the second term? What is the second term? In terms of a1 and d. Okay, can you figure that out? What is a2? Yeah, a2 must be a1 plus d, right? Yes, so a2 is equal to a1 plus d. I hope you agree with that statement. Okay, a2 equal to a1 plus d, because d is the common difference. To find a2 must be a1 plus d. Now the same thing goes for a3. a3 must be, this term here must be a2 plus d. So we have a2 plus d. Okay, but a2, we already know that a2 is equal to a1 plus d. We already write down, okay, up here, that a2 is equal to a1 plus d. We are going to replace a2 equal to a1 plus d. Okay, we are going to replace this a2. Okay, is equal to a2 is equal to a1 plus d and plus d. This is equal to, we can combine this because they are like terms. So a1 plus 2d, right? Now let's continue the process. Okay, for a4 now, we are looking for a4. a4 equal to a3 plus d Now we are doing the same thing for a3. We are going to replace this a3, okay, by this a1 plus 2d. So we have a1 plus 2d, okay, that is a3. We have to add d. Okay, you can combine this. We have a1 plus 2d plus d is equal to 3d. Okay, now by looking at this example or this pattern here, that is A1, we have A1 plus D, this is A1 plus D. For A3 we have A2 plus 2D, right? Now for A4, okay, is equal to, in terms of A1, A and D, we have A1 plus 3D. Can we guess by looking at the pattern that we have, okay, that we have done so far, can we write down what is A5? That is the next term. What is A5 in terms of A1 and D? Yeah, we can guess by looking at this. That is, when n equal to 3, okay, this number here is equal to 2. Reduce 1, right? When n equal to 4, this number here is 3. Reduce 1 also. So when n equal to 5, okay, what will be A5 equal to? So we have to have A1 plus what? Yeah, reduce 1 from 5. So we have 4 times D. Okay, that will be A5 in terms of A1 and D. Okay, can we write down one more terms after A5? That is A6, right? A6 equal to A1 plus reduce 1. Okay, reduce 1 from 6. We have 5D. Okay, and that's the way how to write down the terms as we go down the list. A7, A8, and so on. Now actually we are interested to write down as we go through the process. We would like to write down what is AN. Okay, we are looking for the nth term. Okay, what is the nth term? If we follow this pattern here from, okay, the terms that we already write down, okay, up to this point, okay, can we write down the terms for AN? Of course we have to have A1, because all terms here we have A1, okay, we have A1, each one of these they have A1, so we have to have, for AN, we have to have A1 plus, yes, we have to plus. Now what is the term in this bracket? And at the end here we have D multiplied by D. What is in this bracket here? Okay, when it is 6, it is 5. When n equal to 5, okay, the number here is 4. Reduce 1. Now, what is this number in this bracket when we have n up here? So we have to reduce 1. So how to write down when n reduce 1? We reduce 1 from n. Yeah, we write down n minus 1. Okay, and that will be, okay, that will be the formula to find the nth term. Now in general, for arithmetic sequence, we write down the terms like this. That is, A1 is the first term, we have A2 for the second term, we have A3 the third term, and so on and so forth, up to, for example, we have up to nth term, that is AN. Alright, when we add all these terms together, that is, we write A1 plus A2 plus A3 plus dot 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 plus up to AN. Okay, this is what we call arithmetic series. Okay, if this one is sequence, this is arithmetic sequence, therefore this one is arithmetic series. Okay, when we add the terms in the sequence, we call it series. And okay, we can use this symbol, that is Sn, to represent arithmetic series. Okay, when we add the terms in the sequence together, we call it series, and we have a symbol for it, S. Okay, that S is for sum. Sn means the sum up to nth term. Okay, and in particular we call this sum as nth partial sum. Nth partial sum. Okay, let's explain that by using this example here. That is, if we have this sequence 1, okay, 1, we have 3, we have 5 for example, and then we have 7, and the last term is 9. That is the sequence of odd numbers, okay, up to 9. we stop after 9. There is no other terms. Okay, so when we add these numbers together, it's become series. That is 1 plus 3 plus 5 plus 7 plus 9. Okay, now it's become a series. So what is S1 in this case? So S1 is equal to 1. Okay, the first partial sum is equal to 1. Now S2, that is the second partial sum, is equal to the sum of the first two terms, that is 1 plus 3. Okay, that is equal to 4. That's the second partial sum. Okay, now S3 equal to the sum of the first three terms of the sequence, that is 1 plus 3 plus 5, and so on. Alright, you can continue that. And the last term, or the last partial sum, it will be S5. That is the fifth partial sum. That is equal to, okay, the sum of the whole number, 1 plus 3 plus 5 plus 7 and plus 9. Okay, here we just want to explain what we mean by partial sum. Alright, so again, if we have the what we call the sequence in general, we have A1, A2, A3, and so on up to AN, for example. Okay, if we want to find the sum, okay, we have to find the sum of the sequence. We have this formula, that is, this formula is known, that is Sn equal to n over 2, okay, multiplied by 2a1 plus n minus 1 multiplied by d. Okay, this is the formula to find the partial sum up to nth term. That is Sn equal to n over 2 multiplied by 2 times a1. Remember, a1 is the first term, and d is the common difference, and n is the number of terms in the sequence. Okay, for example, like in our example here, that is 1, 3, 5, 7, and 9. Maybe we can use that example again here. So we have 1, 3, 5, okay, 7, and 9. Okay, when we want to write it in terms of series, we have 1 plus 3 plus 5 plus 7 plus 9. Okay, now the question is, we want to find the sum. That is, okay, if we add them up together, what is the value? What is the sum? Okay, when we add them up. Now we can use this formula, okay, to find the sum. That is, okay, we write S5, okay, that is the sum up to the first 5 terms of the sequence. S5 equal to n equal to 5 over 2, okay, multiplied by 2 times a1. A1 in this case is this, that is 1, plus n minus 1. Okay, n in this case is 5. So 5 minus 1, write it down, 5 minus 1 multiplied by d. D is equal to 2. Okay, now let's see, simplify this and see what will be the answer. Okay, equal to 5 over 2. We have, here we have 2. There we have 4 times 2. That is 8. Equal to, we have 5 over 2 multiplied by 10. This is equal to, this is 5 here. The answer is 25. Okay, so we get the answer, that is the sum. Okay, when we add these numbers here, 1 plus 3 plus 5 plus 7 plus 9 equal to 25 by using this formula. Okay, by using this formula here. Okay, Sn equal to n over 2 and so on. That's the formula we use, okay, to find the formula. Now let's just, okay, manually we add the numbers, see whether we get 25 or not. That is 1 plus 3 plus 5 plus 7 plus 9. See whether we get 25. Okay, let's combine. That is 9 and 1. This one is 10. 7 plus 3, also 10. and we have one more 5 here. So we have 10 plus 10 plus 5. Okay, that's 25, right? Yeah, the answer is the same we get as we use the formula. So our answer by using the formula is correct. And also, we have another formula, okay, to find the partial sum. That is this formula here, Sn equal to n over 2 multiplied by the first term plus the last term. Yes, this is formula number 2, we call it. Okay, formula number 2. Where is formula number 1? Yeah, this is our we call it formula number 1. Okay, for partial sum. Alright, again, we can show that, okay, the formula is correct. That is, if we substitute all the values for this particular example, okay, for this example here, we can get the answer 25 also. Okay, now let's do that. Okay, we want to find the fifth partial sum, that is S5 equal to n equal to 5, so 5 over 2, okay, multiplied by A1 is equal to 1. Okay, see here, the first term is A1, and the last term is 9, right? So plus 9. This is equal to 5 over 2, okay, multiplied by, okay, 9 plus 1 is 10. Okay, this is same as we did before, so the answer is 25 also. You see, okay, so this formula is also valid. That is formula number 2. Get the same answer. You see, 25, all of them 25. Okay. Okay, now what left is, okay, we need to explain actually, okay, where this formula come from. Okay, we have to check and see the origin of this formula. It's very interesting to show. And also, this not only this formula number 1, but also, okay, we can show the origin of the formula number 2. Okay, we need to explain two formula. That is formula for the partial sum, that is Sn equal to n over 2 2a1 plus n minus 1 multiplied by d. Okay, we need to explain this formula. This is formula number 1, and also we have the same Sn we can find by using this formula, that is n over 2, this is a1 plus an, that is the last term. So this formula, for the second formula, we can find Sn by multiplying n over 2 by the sum of the first term and the last term. Add them together and multiply by n over 2, then we have the n's partial sum. Okay, this is formula number 2. So what we need to do first is I need to explain formula number 1 first. Alright, so we do it step by step. Alright, now Sn equal to is the sum of the terms, okay, up to nth term, that is a1 plus a2 plus a3 plus so on, plus up to maybe an minus 1 plus an. The last term is an. You see, starting with the first term and ending term number n. Alright, that is the n's partial sum, Sn. Okay, so we can replace, as we did in the previous showing of the formula, an equal to a1 plus n minus 1 times d. Okay, now this is Sn also equal to, now a1 is equal to a1, yes. Now what is a2? A2 is equal to a1 plus d, right? I hope you still recall, a1 plus d is equal to a2. Okay, plus dot dot dot. Now what is the n's minus 1 term? That is, okay, a1 plus n minus 2 multiplied by d. Okay, that is the an minus 1 term. Now what is an? That is the last term. That is a1 plus n minus 1 multiplied by d. Okay, I hope you still remember the formula that I'm talking about here. That is this formula. Okay, that is an, the nth term equal to a1 plus n minus 1 multiplied by d. Okay. Alright, so this is Sn. We add all these terms together, but at the same time we replace a2 by a1 plus d. Okay, then we add also an minus 1 plus an minus 1 is equal to this a1 plus n minus 2 times d. Okay, that an, that is the last term, will be a1 plus n minus 1 multiplied by d. Okay, that's Sn. Now, okay, remember this one is the second term. Okay, this is a2. Now this is a1. Okay, this is, okay, an minus 1. Alright, this is an. This is an. This is an minus 1. Now this is a2. Okay, this is a1. There are more terms in between, but we are not going to write it down because it is we are not able to write everything down. So now I want to write down again Sn, but this time I want to rearrange, okay, all the terms. Okay, okay, the last term here, that is a1 plus n minus 1 times d, that is the nth term. I want to write it as my first term. Okay, this term, that is a n minus 1, okay, this particular term, I want to write it as my second term. Okay, on the other hand, for this term, that is a1 plus d, this one, this a1 plus d, okay, originally it is a second term, but down here I'm going to write this term as my second last term. Now for the first term up here, that is a1, I want to write it down as my last term. What I mean is, I want to write down Sn now, I want to rearrange all terms. Okay, I want to write down the last one as the first one. Okay, so this one will be the first term. Okay, this one is the second term. Now this one will be my second last term, and this one will be my last term. Now if I do that, okay, what happen is I will have this series, okay, down here, that is Sn equal to, okay, this will be my first term, that is a1 plus n minus 1 multiplied by d. Okay, now that one become my first term. Okay, originally it is the last term, it was the last term, but now it's become my first term. I want to rearrange my term now, plus my second term. Okay, my second term now is the previous second last term. Okay, this term now become my second term. All right, so let's write it down. A1 plus n minus 2 times d. Okay, plus dot dot dot, and then we want to add the second last term. Okay, where is my second last term now? This one. This is my second last term. That is a1 plus d. And I want to write down my last term, last term, that is a1. Okay, my first term now become my last term, that is a1. Okay, they are actually the same, what we call the same series, just that I rearrange the terms. The last term become the first term. Okay, the second last one become the second term. The second last term, okay, we rearrange everything as I explained. I hope you understand what I mean. Now what we do next is, okay, actually they are still the same. They are still the same sequence, Okay, the sum is still the same, just that we arrange the order of the sequence, the terms. Okay, now what we are going to do now next is we want to add. Okay, the first term here, we want to add it with the first term down below here. Okay, like this, we are going to add them together. Okay, now maybe we can call this equation number 1. Okay, this one equation number 2. All right, now what we want to do is equation 1 plus equation 2. See what happened. All right, so we have Sn plus Sn. On the left hand side we have 2Sn. equal to, now the first term in equation number 1, we want to add with the first term in the second equation. Okay, that is, here we have a1, we want to add it with a1 plus n minus 1 times d. Now if we look carefully here, we have a1, and also in this term we have a1 also, so we'll have 2a1, right? Let's add them together. We have 2a1 plus we have n minus 1 times d. Okay, the sum of these will be equal to that, plus. Next, I'm going to add the second term up here. Okay, I want to add it with the second term down here. Okay, so I want to add these two terms together. Okay, that is, maybe we can write it somewhere, okay, to see what is the sum. We have the first term, over there we have a1 plus d. Okay, a1 plus d. Okay, plus we have a1 plus n minus 2 times d. Alright, now let's simplify. Equal to what? a1 plus d, okay, plus a1 plus, okay, nd minus 2d, okay, minus 2d. Now let's simplify. We have a1 and a1, we have 2a1. We can simplify this one. D minus 2d is equal to minus d, but before that we have nd there. Okay, we have plus nd, and d minus 2d we have minus d. Okay, now let's factorize this. So we have 2a1. Okay, we can factor d outside, d, and we have n minus 1. Okay, so the sum is 2a1 plus n minus 1 times d. Okay, the sum of this plus this, as we show it here, equal to this. Okay, that is 2a1. Let's write it down. Okay, is equal to 2a1 plus n minus 1 times d, plus dot dot dot, plus. Now next what we want to add is, okay, the second last term. That is, this second last term, I want to add it with the second last term down here. Okay, I want to add these two numbers together. Now this is the same thing as we did, okay, over here. It's the same as this. That is, just that the position of the numbers, they are different. Now a1 plus d is down here. Okay, for this term we have a1 plus d is up here. Below here we have a1 plus n minus 2 times d is the same thing up here. So when we add this with this, okay, it's the same thing, okay, we did here. So the answer will be still the same. That is 2 a1 plus n minus 1 multiplied by d, plus. Alright, the last term, okay, for this equation and this equation. So that is, we want to add these two numbers. Alright, we want to add this one with that one. And this one is actually the same as, okay, adding this number and this number. Alright, they are the same. You see, here we have a1, here a1. Also here we have a1. Down here we have a1 plus n minus 1 times d. Here we have also a1 plus n minus 1 times d. They are the same thing. So the answer or the sum will be the same. So that is 2a1 plus n minus 1 times d. Alright, so that's, okay, the sum of these two equations. Equation number 1 plus equation number 2. Okay, the sum is down here, below here. Right. So if we look carefully, okay, as what we get for each one of this sum we have, okay, this one with this one with this one and with this term, they are all the same, you know. And all of these actually, they have all together, all of them actually having n terms altogether. We have n terms, okay, because you see, originally we have all together we are adding n term. So this also, okay, the number of terms here also we have n terms. Okay, what that means is on the left hand side we have 2 as n. On the right hand side, okay, since they are adding, we can do it in terms of multiply. So that is equal to n multiplied by, okay, 2a1 plus n minus 1 times d, like this. Okay, we have n number of the terms in the bracket. We are adding the terms in the bracket here n times, or we can multiply. Okay, it's the same meaning. Okay, repeated addition. Okay, we can write it in terms of multiplication. Okay, so we want to find Sn, right? So we want to find Sn. So what we have to do is we have to divide both sides by 2. Okay, so what's left is we have n over 2, 2 times a1 plus n minus 1 multiplied by d. Okay, that is the formula that we call partial sum, n's partial sum, that we need to prove. Okay, this is, okay, the formula for the n's partial sum, and that's the way how to prove it, how to derive the formula. This is the method of doing it. All right, now again, this is the formula number 1. This is formula number 1. Okay, just now I also showed to you, okay, we have the second version of this formula, that is we have Sn equal to n over 2, we have in bracket a1 plus an, right? Now, where this formula come from? All right, where is the origin of this formula? Okay, now let's explain that, okay, by using this formula. Actually, this formula number 2 is coming from formula number 1. All right, how to explain that? Okay, let's do it down here. Okay, let's write down again formula number 1, that is Sn, okay, equal to n over 2, 2 times a1 plus n minus 1 multiplied by d, like this. Okay, now let's break down the terms in the bracket. Okay, that is equal to n over 2. In bracket here we have 2a1 means a1, okay, a1 plus a1 plus n minus 1 multiplied by d, right? Okay, what I did was, okay, writing, instead of writing 2a1, okay, instead of writing 2a1, I write it as a1 plus a1. They are the same thing. All right, now this is equal to what? Equal to, we have n over 2, okay, we have a1, that is this a1, plus, now this whole term here, see, we have a1 plus n minus 1 times d, okay, plus, let me write it in bracket. No need. Okay, we write it like this. Okay, and that term is a1 plus n minus 1 times d. This is actually an, right? This is an.